Hi, I'm Jill, and today we're going to be talking about slant asymptotes. On this graph, the slant asymptote is shown by the blue line. As x gets extreme in either the positive direction or the negative direction, the graph gets closer and closer to that line. How does that happen? A straight line has an equation that looks like y equals mx plus b, where m is the slope and b is the y-intercept. What else has an equation that looks like that? Recall that a rational function is the quotient of two polynomials. That doesn't look like y equals mx plus b. One way to look at that rational function is as a division problem. Carry out the division. In this case, you get y equals x plus a remainder. Y equals x is a straight line. What about the remainder? In this example, when x is close to 1, the remainder's denominator is close to 0. So when you carry out the division, you get a number that's very large in absolute value. And at the point where the denominator is equal to 0, the function is undefined. That's a vertical asymptote, a topic for a different day. The remainder is the difference between the function and the asymptote. Where the remainder is large, that is, near the place where the remainder's denominator equals 0, there's a big difference between the function and the asymptote. Where the remainder is small, that is, far from the place where the remainder's denominator is equal to 0, the function is close to the slant asymptote. Here's another example, this one with a more complicated rational function, but still, when you divide it, it comes down to a straight line plus a remainder. Does that work for every rational function? Well, no. Well, then which ones does it work for? Our straight line, y equals mx plus b, is a first degree equation. It starts with 1 degree of x. How do you get that? That happens in a rational function when the degree of the numerator is 1 more than the degree of the denominator. In that case, carrying out the division gives you a straight line plus a remainder. The straight line is the slant asymptote. The remainder is the difference between the slant asymptote and the function. So what's the take home? You get a slant asymptote in a rational expression when the degree of the numerator is 1 more than the degree of the denominator. To find that slant asymptote, you divide the numerator by the denominator. The quotient without the remainder is the slant asymptote. I'll be watching for your comments. Leave me a question and I will answer it.